All right. Well, we're going to talk about how to find limits using a graph. There are a lot of different graphs, and sometimes it can be very complex, but understanding how limits work with a graph is one of the three basic strong components that you need to know when solving limit problems. The first thing that we have here is we are going to find the limit, and I have a bunch of different ones, the limit of f of x as x approaches -3 from the right. Okay, so this is our one-sided limit. So what we look at right here, this is f of x. And we're going to find -3 as we approach to the right. So first off, we're going to try to identify -3. So 1, 2, 3. So here's -3. And we're going to approach this value from the right. Now, usually what I do is I like to take my pencil or my finger or whatnot, and I like to look at the graph and what happens as I get closer to this value or this point, -3. So as I approach this from -3 to the right, it appears, and I use a little arrow, it looks like it's going to which value? Well, hopefully you said to yourself, it's approaching 0, and you are absolutely correct. The limit as x approaches -3 to the right is approaching 0. It's approaching 0. Now, the limit as x approaches -3 to the left of this function f of x, this is a little bit different. Because as we approach here, we go left to -3, because -3 is right there. We can see that it's approaching, well, you guessed it, 1, 2, it's approaching -2. What does that tell us? Well, that tells us that the limit as x approaches -3, because this is a two-sided limit for this function f of x, this limit does not exist. Does not exist because it approaches two different values from the right and left side. All right, so with that, we can find some different values. Let's say I ask us, I'm going to actually get rid of this then. I can go to our next thing. All right, now we'll cancel this out. All right, let's try to find this limit. All right, the limit as x approaches, or f of x as x approaches 0 to the right. Well, approaching 0. 0 is located right here, and we're approaching 0 to the right. Well, I'm going to take my little pencil and I'm going to dot it, and it appears that is going down to -infinity. So that's going down to -infinity. We can also look at it and say, okay, if we take the limit as x approaches 0 to the left of the function, we can see that this right here, approaching left, it's going to positive infinity. And therefore, the limit as x approaches 0, normally this wouldn't exist anyway because infinity is not a value. But because they even go in two different directions, we would say this limit doesn't exist because it approaches two different infinities. All right? Hopefully you're getting the hang of this. We're going to try some more. Let's look and see what we got here. Oh, here we go. Let's try this one. Let's take the limit as x approaches 3 to the left. X approaches 3 to the left. Well, we're going to approach x approaching 3 to the left. Well, 3, let's find that. We've got 1, 2, and 3. Okay, so here's 3. Well, we're going to approach 3 from the left. So that means going to 3 to the left, I'm going to go and approach 3 right here. And where does it look like it's going to? It appears that it's approaching, look at there, it's going to 2. Well, the limit as x approaches 3, let's just try to the right of this function. Well, I go this way, to the right of 3, and it also appears that it's approaching 2. Well, since they approach the same value, unlike all of our other ones we've been dealing with, the limit as f of x approaches 3 is actually going to equal 2, because these two values are approaching the same one. So this limit does exist. Now, sometimes students get a little confused between limits, especially when they start doing them algebraically, because you use something called Trig Substitution, and we just plug the values in. Limits are not the actual value of the function. Limits are the intended height, what you get arbitrarily close to, the value that you are approaching. So if I would ask what is actually f of 3, we can see right here that f of 3 is not equal to 2. There's a hole here. And we actually see that there is a closed-in circle up here, actually at 4, because f of 3 is actually equal to 4. That's a little weird. A lot of students get a little agitated by that because they're wondering, why did they put that up there? I don't know. Get over it. It just is. It's an arbitrary point that it was placed above there because maybe it was some sort of data that didn't work out. But in any case, it's not at 2. Okay, so what we have is remove this discontinuity and then a value at 3 at 4. All right, well, let's try a couple other ones, final ones, and let's look what happens when we go to infinity. Let's look at infinity. I'll take this and I'll eliminate this value right here. All right, let's get rid of this stuff. Okay, and let's check out infinity. Infinity is like horizontal asymptotes, okay? Because what happens, where is the height going to as we go to positive, negative infinity? Well, looking at this, if we go to infinity, that means infinity is way out there. As x approaches infinity, we can't even see infinity, all right? We only have just a small section of what infinity is. But at times, we can see what a graph is approaching. And as we look at this, and as we go to infinity, we start to see if it converges, or if we see it start leveling off. It's essentially a horizontal asymptote, a right end behavior. Probably talked about that a lot in a pre-calculus class when you talk about rational functions. End behaviors are horizontal asymptotes. And essentially, we're trying to figure out what is a horizontal asymptote. Well, we can see this one. It appears that this horizontal asymptote is 3. So as x approaches infinity, the intended height appears to be approaching 3. We can do the same thing on the left side. This would be a left end behavior. Okay, which is also a horizontal asymptote, but it's to the left. Usually they're the same, but at times they're not. So as we go this way, as I go to negative infinity, because remember this is when x is going to negative infinity, all right, and we can see that it appears either this is going to negative 1/4, or I would just say it's approaching 0. Okay, this is approaching 0. So the end behavior, or the horizontal asymptote, would be y equals 0, and to the right, this would be y equals 3, and those are your 2 limits. So we went through several examples on how to find limits using a graph. Be careful when you're using that is that you understand that limits are the intended value. It looks like what it's approaching, not what it actually is. Hopefully this will help you out in solving some other problems that you may encounter in the future. Good luck and God bless.